Detection capability is one of the standard validation parameters for flow cytometric methods. Detection capability encapsulates a set of performance attributes used to characterize measurement accuracy and precision at low end of measuring intervals. An assay's LOB is the highest signal obtained in the absence of the measurand, whereas LLOD is the lowest amount of measurand consistently detected. LLOQ refers to the ability to precisely and accurately measure low amounts of measurand. Detection capability assessment is important in various scenarios. Depending on an assay's intended use and regulatory status, different approaches can be employed for detection capability evaluation. In a clinical setting, LOB evaluation is done using samples with the absence of measurand. LOB is established empirically by repeatedly measuring blank samples. LLOD is determined empirically or estimated using the formula. LLOQ is established by analyzing samples with levels of measurand approaching the LOB or LLOD. In clinical settings, samples with varying levels of population of interest are admixed with samples lacking that population. LLOQ is established using minimum 5 levels for each of 3 donors or using 5 or more clinical samples in triplicates near the LLOQ. LLOQ is established when these conditions are met. Precision evaluation using standard deviation or %CV make up the acceptance criteria. For the quantitative BD stem cell enumeration kit, a 10-day LOB study was performed across 3 BD FACSLyric flow cytometers using cell-free plasma extracted from normal peripheral blood stained in 6 replicates. For the qualitative BD one-flow chronic lymphoproliferative diseases limited panel, an abnormal specimen was added to a hematologically normal peripheral blood specimen. Various target populations were assessed at these concentrations for LLOD determination. For the quantitative BD multitest 6-color TBNK reagent, whole blood was diluted using cell-free plasma to achieve 4 different concentrations of population of interest to determine LLOQ. The appropriate validation approach depends on the assay's intended use and associated regulatory environment. If labs implement assays like the BD stem cell enumeration kit or the BD one-flow CLPD panel approved for use as an IVD or CE, a method verification instead of validation is recommended. The lab's objective is to verify that the manufacturer established performance parameters can be replicated. For IVD-approved CE-marked assay verification, detection capability evaluation is optional during validation. Depending on an assay's intended use and associated regulatory status, full detection capability validation strategies require analysis of multiple samples acquired in 3 to 5 replicates.